Today we make a vise. When it comes to vices, there's three options. You can either build, you can buy, or you can restore. It's always cool if you can find a big vise at a yard sale or a swap meet and restore one of them, or even if you're lucky to find one in good condition that you can use in your shop. Or the other option is you're gonna have to buy one, which means go to Amazon, read reviews, find a vise that actually works. Or option number 3 is build one. That's what we're gonna do today, is build a vise. This is a 924.5 Starrett. The jaw capacity is 8 inches, and I found myself running into this maximum capacity often to where my part just does not fit in between here. So building a vise that has a larger opening is pretty appealing to me. I'd like to keep the price around $200 to build this and the weight around 70 pounds, and I want the jaws to be about 5 inches wide. This kind of puts this in the same range as all the vices you can buy on Amazon, and a pretty good price range if you were to buy a used one. I think this is going to be the main structure of the whole vise. It's a piece of 3x4 tubing, 1/4 inch wall, and it's approximately like 21 inches long. We're going to lop it down. We're going to find another tube that fits inside of it, and I can already tell I'm going to have to get rid of this weld seam, so I think we should tackle that right now. If you're wondering how I stripped the weld out of this piece of tubing, I have a video about it, so go check it out. Got the weld ripped out of this 3x4 piece of tubing. I got 22, 23 inches of body. This is going to give me a little bit more flexibility to clamp long pieces in between the jaws, unlike my Starrett here, which I'm only limited about 8 inches. This is our sliding, moving jaw. It's going to move in and out of the tubing. When the jaws come together, there's a section of this tube that we're going to use as kind of like a shelf. So by just cutting it to 45, we get a little bit of extra support. But I think the next part I want to tackle is the fixed jaw. So I'm going to make a piece of plate steel in the shape of a jaw, and we're going to sandwich this body of this tube with it and weld it on. That's how this is going to look. Here's what we got so far. I got these plates cut out on the water jet. I added these cool little chamfers on the edge of this plate just to add a little bit of style. The load is going to be transferred all the way down into the ground with this design and into the sidewall of the tubing, which has the most strength, and not on this top surface here. I'm not going to weld on the side here. I kind of like that clean line. If you were to build something like this at home, this doesn't have to have all this style. You could have a square block, for crying out loud. It doesn't have to be too fancy. Got a little bit of movement. I might have to come back and add some sort of gib or a shim or an adjustment to kind of pull some of this slop out of here. But after I get this thing all welded together, I'll address that. The next step we're going to do is cut a block and machine 2 holes on the back side of it, and this axis right here is going to give us room to bolt a soft jaw to it. I got the vise jaws all finished up here. I used a piece of 1x2 piece of cold rolled bar, and then I attached a 1x1 aluminum soft jaw to it, and then I just fastened the soft jaw to the back with a 5/16 socket headed cap screw, and I positioned them to where they fit in between these plates here on the vise. And two, I made it tall enough or wide enough here that I can come back and I can machine it off at a later date when these get damaged. And these are going to get beat up. They are just going to get destroyed, but they're really easy to make. And I'd like to have one vise around here that just has these disposable jaws on there that are cheap. But before I get this welded on, I want to get the lead screw in here so that we can slam the vise closed together with the lead screw. And then after I get all the tension into the vise, we can tap. This is exciting. We got all our parts machined and ready to get this screw and vise assembly together. In order to keep this dynamic jaw all one piece, we need to have an extension tube that can run inside of this. And this is what you're seeing right here, this 1 3/4 inch piece of tube steel. I welded 2 nuts on the end, and it goes all the way back through here and it gets welded to this end cap. So virtually we're pulling from the end of the vise to this jaw, which is pretty neat. This is a Prentice vise, and this is what you typically see. This nut is mechanically fastened to the static body of the vise. And one design flaw that I don't like about this is you have to split the dynamic jaw to give clearance for it. And when you do that, you get a potential weakness. Much like this vise needs some repair, and you can tell that it has actually split. There's a crack that runs a good 8 inches down the middle of this Prentice vise, okay, because of this design. This is one thing I like about the tube steel vise, is that I'm able to keep this dynamic moving jaw all one piece, and we're able to do this by basically extending the nut all the way from the back to the front. So it's fastened at the back of the body instead of the middle, and we just welded this nut to a 1 3/4 inch piece of tubing, and I plug welded it. There's 2 nuts in there, so it should be plenty strong. But now we have no split down our moving jaw, so this should be really strong. I really like this design. I think it's going to work really well. And this will also allow full extension of the vise jaw. So let's put this all together. You're probably wondering why I didn't use a piece of Acme thread or a trapezoidal or buttress thread. Well, for one, I wanted to keep the price low, and this all thread is super cheap and it's readily available at any time. But more than anything, I really wanted the 8 threads per inch. The 8 threads per inch is going to give me really high clamping force with little effort on the handle. This nut, where the balance point is pretty close to center, so when I spin it around there, my finger, I got some balance, and then when I want extra load, I can put the nut in here, spin it around the end, okay? And then it just fits right here in the vise when we're done. I have an idea to build a swivel base for this vise, and I think I know where some material is that we can use. This is the little drop out of the go-kart belt grinder frame. I think this piece will work perfect to be able to cut out the base for that swivel for the vise. Doubled beveled outside. This is gonna look hot. This is the main body ring. This is that 1 1/8 plate that we used on the go-kart belt grinder build. And there's a bevel on the bottom and a bevel on the top and 2 bevels on the side. It kind of gives it this cool casting look. And the 2 5/8 holes here on the end for the ears, they line up perfectly with a fixture table. So if I wanted to bolt this down to one of these tables, I could do that. But it works something like this. This is the bottom plate, and it has the matching bevel to the bottom of this one. And it can go like that, okay? And then we have a matching top plate with a matching bevel, and this bevel, I think I put it at 50 degrees on the top, and it's a 30-degree bevel on the bottom. And basically they go together just like that. And we use, these are the little magic square thumb screws. And there we go. So now it's just a 1/4 turn and it swivels. Okay? You get it where you want it, and then you lock it back down again. I was hoping that I wouldn't have to turn it in the lathe, but it seems to be working really good, just fresh out of the water jet with some light cleanup and some deburring. And I think it turned out pretty cool. It looks like a casted part. It's gonna add some style to this vise. Now that I have all the pieces here, I'm ready to weld this thing out. performance of the vise exceeds all my expectations with just simple parts with tube and plate. Actually puts my Starrett vise over there to shame. It operates really similar to my Kurt vise on the milling machine. With the thrust bearings added in the front and the back of this dynamic jaw, man, the movement is just so utterly smooth. It just wants to just continue to go in or out just by itself. And having the handle in speed mode, I call it, where it's halfway, a little short 3-inch handle, I'm really able to move the vise fairly quickly. And when I want to really crank down on something, I can move it to the torque mode and really put the beans on it. I think now it's a must to add thrust bearings on all the vices. It just really improves the feel of the operation of the vise. It's often my projects are too big for the vices I have in here in the shop, so the extra capacity that this vise offers is going to be great. I thought I was going to have to add some way to adjust the slop inside the two tubes, but it's actually pretty close. When you pull it out, it closes repeatably, and there's probably a 1/16 of an inch of movement in there, maybe a little bit less. The swivel works pretty good. Let's loosen it up a little bit more. Those tapers in there seem to really be holding the vise secure. Let's test it on the clamping force. Well, if the table moves, you know you're probably pretty good. So I consider that a success. The swivel plate seems to be locking pretty good. It's definitely heavy. Yeah. 87.9 pounds. Yeah, I overbuilt it. I tried to stay under 70 pounds, but it just wasn't happening. I didn't want to take any shortcuts anywhere, but I also don't have anything extra on here that's unnecessary either. So I think the weight is appropriate for its size and what it can do. If you'd like to build this vise in your own shop or give it a try and have some extra clamping capacity, I have some drawings to be able to download on the Fireball Tool website. There's a link in the description below. Next time you see this vise, we're going to be testing its build quality and function in a build, buy, or restore vise contest. So thank you guys for watching, and I'll definitely catch you on the next one.